Okay, thank you. I'm just trying to figure out, can you guys see my presenter mode here, or can you just see the full screen?
We see the presenter mode with the slide on the left, and there you go.
There we go. All right. Okay, well, it's a pleasure to be talking with you today. My name's Katie Wilson, and I'm presenting here with Pat Skinner. We are research scientists. We're with OU CIMMS, but we're at NOAA NSSL here in Norman. And we work with the Warner Forecast group. My specialty is working with end users. I've done a lot of work in the hazardous weather testbed. I'm meteorology and training, but very interested in human factors and some of the more interdisciplinary research questions. And Pat it has a lot of expertise and insight in the model and interpreting what the model is showing. And he does a lot of the post-processing for the group. So we're going to provide some background on what Warner Forecast is and provide some examples and give you guys an opportunity to ask some questions. Okay, so let's see. There we go. So you may already have heard of facets. This is, you could think of it as a concept or a paradigm that NOAA is following when thinking about what the future forecasting process might look like. And facets is drawing on two different things. So first of all, we a lot of deterministic guidance and forecasts, but the desire is to move to more probabilistic guidance and to also have a more continuous flow of that information. So there are gaps at the moment in the guidance that forecasters can see and the forecasts that the public are receiving, and so we're trying to fill in those gaps. And with this approach, there are different topics that need to be considered with every development, and so you can see those different topics on the screen here in these different icons. So it starts with grid-based threat probabilities, using observations and guidance, the forecaster, which is you guys. How do you use the information that's being provided? How do we display that in threat grid tools? And then how is that translated to usable output by end users, if that's your stakeholders like EMs, maybe your local broadcast meteorologists, as well as the public? How do you elicit effective response? And then verification. And verification is twofold. First of all, the verification of how the guidance did or the forecast compared to observations, but also verification and how the public responded. Did they take the desired action? And so Warner Forecast is following this facets paradigm. And just to drive this idea home a little bit more, what we have here is just a graphic showing a continuum in time and space from days ahead, looking on the regional scale. And so, for example, the guidance that SPC might provide in convective outlooks. And then we have watches that are issued, and then that goes all the way down to warnings that are issued by local forecast offices. And that's really looking minutes before an event or perhaps when the event is happening. And so what we have that at the moment are information voids. And so between the watch and the warning, we have an information void. And so the official products that go out, we see the watch and then the warning, but there's a lot that happens in the meantime and a lot of evolution, but not necessarily a way to visualize what that evolution might be or to communicate it to end users. And so this information void is looking to be addressed with Warner Forecast. And so at the moment, Warner Forecast has provided guidance out to 6 hours. And so we're looking to try and fill this gap right here. There's a lot of different type of work that the Warner Forecast group is doing, and this graphic here is just trying to hone in on what those different things are. And so we start at the top with research and development. For over a decade now, the Warner Forecast group has been developing a model. Originally, it was focused on the tornado threat. These days, the Warner Forecast system is able to forecast a variety of different hazards. But this is more of what you might think as the traditional physical scientist role of looking at data assimilation, the physics and numerics that go into the model, and the post-processing, which Pat has been leading for some time now. And then being able to develop and improve the performance of the system. And then there are other aspects. And so for the past, I guess it was since 2016, 2017 timeframe, we were ready to start showing the output to end users. And so we started doing work with forecasters and trying to get feedback on what the guidance provided to them and how we could perhaps improve it. And then we can go back to the scientists, share those ideas, and determine the most appropriate areas for improvement. But a really big part of what we're doing right now is demonstrating this system in a real-time environment as well as an experimental environment. And the way that we do that is we have, it doesn't run year-round, it runs at the moment during specific seasons where we have plans to do experiments. So right now it's running during the spring forecasting experiment. And it is the domain is being guided by the Storm Prediction Center. And then in the summertime, we'll be running again, and the domain will be directed by a project that we're doing with WPC. So there's a lot of different types of guidance that the Warner Forecast system provides. And this, in a nutshell, is some of the products that you'll see if you go to the website. And so there are different ways to represent and visualize probabilities. And these three representations here can tell you a lot about the forecast. And so on the left, this is the probability of exceeding some kind of threshold. And so what you're seeing here is the probability of exceeding 2 to 5 kilometer updraft helicity that exceeds 60 meters squared per second squared. But you can look at this kind of diagram, for example, for a hail threshold or a surface wind or a QPF threshold. And so it's telling you about the likelihood of exceeding a threshold. The middle panel is showing percentile products. And so if you look on the website, you'll see different percentile products, and that tells us about the severity. So if something happens, what's the reasonable worst case scenario that we could expect from this event? And so this is also showing 2 to 5 kilometer updraft helicity, but this is the 90th percentile. And so Pat likes to describe this as the reasonable maximum. If we take the maximum, the 100th percentile, that it can sometimes be an anomaly or an outlier. So the 90th is more of a reasonable guess. On the right-hand side, we've got paint pool products. And so this is a way that we can see the distribution of all 18 members. And so Warner Forecast does have 18 members. And by looking at this product, we can look at the spread and the distribution and the extent of agreement among members. Okay, so Pat now is going to give some background on what the website looks like and give an example of an event from just the past week or so. So Pat, do you want to share your screen, or do you want me to advance for you?
Do you mind just advancing? I've only got a few slides, so that should be, I think, the easiest.
Okay.
Okay. All right. Thank you, Katie. And yeah, so as you mentioned, I'm going to talk a bit about how to access the guidance from Warner Forecast System online, and then I'm going to show examples from last week. And I just want to highlight a couple of aspects of WoFS that may be different than other CIMMS and CIM ensembles, and just some of the forecast situations where it may be useful. So to start with, we do have a new real-time web viewer, which we're all very excited about. This is redesigned by Brett Roberts, who also redesigned designed the SPC href viewer. So it shares a lot of the functionality and characteristics of that viewer, and we're pretty excited. We think it's easier to use than last year's version, and we've also been able to shrink the file size of the images so they load faster. So we think we've made it a little bit more user-friendly than it's been in the past. I'll mention in the upper left corner, you can see there's this dataset tab. And so we're actually running not just the Warner Forecast system, that's the primary system that we're running to provide real-time guidance, but we also are running 2 deterministic models with 1.5 kilometer grid spacing. These are initialized in different ways. So one's done using variational data assimilation, and one's doing a hybrid of variational and the ensemble-based data assimilation that WoFS uses. And this is something that's more of a research project, because we want to know how do we best optimally assimilate the data to produce a usable forecast. But you do have these 2 deterministic members with very high resolution that are available in real time alongside WoFS. So we also are then running overnight, rerunning the WoFS forecasts with 9 members instead of 18 members at 1.5 kilometer resolution. So they will not be available in real time, but the next day you can go back and look at what the forecast may have looked like in WoFS if it were run with basically twice the horizontal resolution. So that's a few things you can look at on the website. Other things, as you can see, there's a date menu at the top and a run menu. Those should populate and show you the available days and the available times. It's an experimental system, so we don't run every day. We typically don't run weekends. We're tied to the spring forecasting experiment in May, and then we're collaborating with WPC over the summer, and so we have them pick the domain of the day based on where they think the heavy rainfall threat is the highest. So it will run intermittently, but when it is running, the date should pop up in the menu, and then you can look at all the different initialization times through the run menu. And we have general information on the environment. That's normally ensemble mean values. And then we have probabilistic information on both, synthetic radar and satellite imagery, QPF, and severe fields like hailcast or damaging straight line winds, multiple measures of rotation, and then paintball plots for different hazards. So we not only provide reflectivity paintballs, we also provide paintballs of 30-minute rotation tracks and damaging wind swaths and hail exceeding 1 or 2 inches. And it's not up and running yet, but we should have verification available where we can have ASOS overlays and then also MRMS overlays. So you can look at the output of the MRMS data on the WoFS domain, and we also would hopefully will have MRMS paintballs you'll be able to toggle on onto and off of any product, maybe by the end of the week. So Katie, if you go to the next slide. Thank you. So that's an overview of how to get the guidance, and I just wanted to highlight a couple aspects from cases last week. So I was going to start with on May 5th, which I think was last Monday. And this is an event where you had basically a long track supercell that developed in a somewhat marginal environment and tracked across most of northern South Carolina. And it ended up being a real highlight case for WoFS, mainly because one of the goals is we want to move beyond providing the regional guidance that you see on the watch scale and onto storm scale guidance, so something that's akin to predicting the individual thunderstorms. And in this case, WoFS picked up on the signal of this supercell developing and having a pretty long track to it early on, and this is a 6-hour forecast that was initialized at 20 UTC or around the time of initiation. And it doesn't match the eventual MRMS level of a rotation track perfectly, but it's pretty good. I mean, it's within a county for most of that 6-hour track. So this is basically a nice example of what we want the system to be able to do, which is lock into the tracks of individual thunderstorms and predict their evolution and severity. So this is something that would be held up as something of an ideal case. It doesn't always work this well, but that's a nice illustration of what the overarching goal is for the system. And if we go to the next slide. The other thing I was going to show is how do we get to the point where we're able to predict an individual thunderstorm? And that really is driven by rapidly cycled assimilation of radar and satellite data. WoFS assimilates reflectivity and radial velocity observations from the WSR88D network, and also GO16 cloud water path and clear air radiances every 15 minutes. And so other systems like the Hurry assimilate these data every hour, but these extra assimilation cycles help to spin up the individual thunderstorms and get an accurate analysis more quickly, and hopefully should improve the resulting forecast. That's a basic principle here. And so I'm going to show a series of paintball plots from last Thursday, May 7th, and they're all going to be valid at 1 UTC. And we're just going to look closer and closer to the event time and see how the guidance changes as you begin to assimilate the radar and satellite observations. So beginning at 19Z, this is pre-CI. This is something we've only been assimilating, in this case, Oklahoma Mesonet ASOS observations for a couple hours. So we're probably still very similar to what the Hurry prediction is at this time, which is what we use for our initial conditions. And you can see there's a regional threat of thunderstorms, basically from western Oklahoma into central Kansas and North Texas. So if we step forward in time, you're still pre-CI, you still see mainly a regional threat. You can see, though, there's some of these larger paintballs. If you look at the different shapes, especially along the Red River and southward into North Texas, you can see something that looks a little bit meatier in terms of the reflectivity paintball. So you can see something that may hint at preferred storm corridors developing, maybe in Northwest Oklahoma and North Texas. And this is 20 UTC, and CI is going to be occurring basically between 20 and 21 UTC. So if we go to 21 UTC's forecast, okay, This has now got some of the information that we've been able to assimilate from the radar and satellite, and you can see that the system is beginning to lock on to preferred storm tracks. So you can see that most of the larger pink balls in North Texas are now starting to cluster over a tier of about 8 to 10 counties. So it's still not really on a specific storm track, but you're starting to basically refine and provide more specific guidance of where the thunderstorm threats are. And there's two basic areas. There's North Texas and there's also Northwest Oklahoma. You can also see, and I highlighted there because I think it's neat, once you start to lock into specifics of storm evolution, you can also then see added storm scale details. So these smaller paint balls that are going into Southwest Oklahoma, I don't have the loop available, but if you go to the web viewer and loop it, you can see that these are all left movers. So this is all splits from immediately after initiation of the large supercell in Northwest Texas. Okay, and so if we go to the next hour, so this is with another 5 cycles of radar and satellite data, the system's really beginning to lock onto a solution. So now you can see there's clearly 2 areas of preferred storm tracks. You have one large right-moving supercell in North Texas. You can see there's still semblance of left movers in Southwest Oklahoma. And you also have this area basically in Northwest Oklahoma where you have a high confidence of a supercell being predicted. So one thing that's interesting here is that one of these forecasts turned out to be pretty good, which is the one in North Texas and with the left movers going to Southwest Oklahoma. The other one that's basically all of the convection in Southwest Kansas or central Kansas through Northwest Oklahoma and into the Northeast Texas Panhandle, all of that is spurious. All of that's resulting from over-aggressive prediction of CI. So that highlights another aspect of WoFS that I think is unique, which is because most of the forecast quality is driven by the assimilation of radar and satellite data, you can have really dramatic variation in the quality of prediction for different storms in the same domain. So when you look at it, you can look at the observations and you can tell whether or not, if it has an accurate analysis, it's more likely to have an accurate prediction. If something looks kind of fishy based on what you think in the observations, then I'd treat it with a grain of salt. Okay, and if we go to the 2-hour forecast, the next slide. In this one, this is just showing with additional assimilation, you have basically really locked onto the track of the Northwest Texas or the Northern Texas supercell. And Katie, if you toggle between the last 2 slides really quickly. Another interesting thing is you notice that the Northwest Oklahoma storms have all retreated back into Southwest Kansas. And what's happening there is that WoFS is continuing to predict CI spuriously, but because it's starting from initial condition without the storms, it's basically reining those storms in. It's drawing them back with each forecast. And CI did eventually occur there. It was just WoFS was too early. So that was what I wanted to show with May 7th, and I wanted to highlight one other aspect of this, which I thought was interesting. So on the next slide, this is now loops from our 1.5 kilometer forecasts. And it shows on the left the 90th percentile, a reasonable worst case scenario from the 2 to 5 kilometer updraft velocity. And then on the right, the 0 to 2 kilometer updraft velocity. So you're looking at basically a representation of the intensity of the mid-level mesocyclone on the left and the low-level mesocyclone on the right. And this is something we really hope is something that we're able to capture at higher resolutions, which is to better discriminate between storm intensity and the likelihood of specific hazards. So this is showing that you have basically an intense supercell, but without really strong rollover rotation, so that we might be able to say with more confidence that this is less likely to be tornadic. And this did turn out to be a non-tornadic storm. In fairness, the 3 kilometer one actually predicted this much better than we have typically seen in the past. But this illustrates what I think is one major motivation for going to higher resolution in the future, which is you can not just get the track and relative intensity of a storm predicted correctly, but you can actually start to look at some of the storm scale details like low-level mesocyclogenesis. And so those are what I really wanted to highlight today. I'm happy to take any other questions or requests at the end of the talk, but I'm going to turn it back to Katie now.
All right, thank you, Pat. So this is just 1 or 2 examples of the many cases that 1-hour forecast has run for. And Pat's insight is really interesting, but we're also interested not just from the developer's point of view, but how is this information useful to forecasters? And so since 2017, we've been working with forecasters as an end user group to try and understand what this guidance will mean to them. And so we started off by, first of all, just looking at, well, what do forecasters think when they see this guidance? How do they interpret it? There's a huge amount of literature that looks at the public's interpretation of probabilistic information, but we were interested in, well, what about the experts? And so what I'm showing here on this slide is a variety of different work that we've done with forecasters. And in the top left, during it was a 2017 spring forecasting experiment, we worked with the participants. So we had forecasters, model developers, people with meteorology training, and we issued a survey to try and learn about their understanding and where there might be misinterpretation. And that research was published, but it was also a springboard for developing some training. And so in the 2019 spring forecasting experiment, before forecasters and other attendees used the guidance during an experimental task, they received some training, and we were also able to look at the effectiveness of the training by having two different groups. One group received the training and then did a test, and then the other group did a test and then received the training. And so we're kind of working in that area to see how do we best prepare forecasters if this goes operational. What's the kind of training content that you guys need? And then in the top right, I mentioned we do different experimental tasks during the spring forecasting experiment. For example, we've had forecasters issuing 1 hour and 4 hour outlooks for total severe weather. And we're also looking at their product usage. And so during these tasks, how do forecasters navigate the many one-on-forecast products? We've got a lot of products on the website, and the newer website is organized really nicely. But we're doing a product analysis with the past website, and we're trying to look at the similarity, the patterns in which forecasters access the products. And if one-on-forecast were to come to your office and if forecasters were to say, okay, well, where do I start? What's best to look at? Perhaps we're able to provide some typical routines for looking at the guidance for different types of events. And so we've done experimental work, but we've also done real-time work. Part of that has been, it started off in the Norman Forecast office. It's pretty convenient since they're right next door to where we are. We're actually, they're in the same building right downstairs. And so Pat and I have worked with them during real-time events to look at how they'll use one-on-forecast guidance, and the middle figure, the one here that's got the yellow and the red bubbles. The Norman office did issue experimental products out to the public on this day to highlight specific areas with more specific timing for what kind of threats to expect. We've also been working with WPC for the past few years now. We have a really nice collaboration with the MetWatch forecasters, and we've been looking at how they could use one-on-forecast to issue MPDs. And so that's been interesting because that's a product typically that's issued between the watch and the warning time frame. But rainfall has been a very good focus for one-on-forecast, and we've learned a lot. We're interested in forecasters, how do they use this information, but we're also interested in other aspects such as forecasters' workload and confidence when using this information within their typical forecast routines. We're interested in how they perceive the different attributes of the forecast and how they performed. So you can see in this image here, we get ratings for things like location, coverage, timing, intensity, and the convective mode to try and understand, when forecasters think that a one-on-forecast forecast is performing well or it's excellent. What does that mean? What does it mean in terms of quality? How can we add value to the forecast process? And then on the right here, this is an experiment that we did in collaboration with the Norman Hydro Group. We were able to force their flash model with QPF from the one-on-forecast system to provide probabilistic flash flood guidance products. And from that experiment, we did determine that the availability of these forecasts out to 3 hours where QPF is added compared to the scenario where you only see QPE, we do see that results in earlier awareness. So that's the blue boxes here. You can see in the second panel, there's more awareness of areas where flash flooding might be a problem, and also earlier decisions. And so for flash flooding, we're seeing benefits and applications already. Okay, so this slide here just talks about some of the benefits of expert evaluation. And when we say expert evaluation, we mean you, the forecasters. So we can learn a lot by collaborating with forecasters and getting your input. And so the first point talks about the independent evaluations of WoFS forecast quality and potential value. And so we can learn about the storm impacts. What does it tell you about storm impacts that you didn't already know with the guidance that you already usually have available? You are able to identify what you might call unphysical or erroneous storm evolutions, things that within your expert conceptual models, is there something in the guidance that just doesn't make sense? Something that perhaps we as physical scientists or, without that forecast expertise wouldn't identify? And are you able to identify specific forecast scenarios where the system is providing potentially valuable information? And then we're also interested in the improved understanding of best practices for disseminating WoFS guidance. And so once you've got that guidance in your hands, well, how is it integrated into the forecast decision-making process? We know that there's been a lot of work looking at the role of the meso-analyst, and so we're trying to understand, where does warn-on forecast fit? Is it under the meso-analyst position? How does that impact the downstream warning decisions that are made? There are a lot of research questions embedded here. Also thinking about the limitations of the current system that we have. So the way in which it's visualized, the way in which it's disseminated. It is a web viewer right now. We're working with a developer who's trying to get it into AWIPS. That will be some time yet, but that's something we're working on. And what are the expert user preferences in the guidance products? Like I mentioned, there's a lot of guidance products that are available, but what is most useful to forecasters? And if when it comes to the time when it's implemented into AWIPS, if we can only have a subset of products, what do you want to see? And then the question of what might potential public-facing products informed by the warn-on forecast system guidance look like? And so, as I mentioned, the Norman Forecast Office has been playing with that a little bit. We don't have an answer right now. We don't know what it should look like or what would be the most effective for emergency managers or the general public who might be seeing these graphics. If the broadcast meteorologists take them and plop them on the screen, what will that mean to the public? These are all open questions right now. And then finally, the feedback, this gets back to that first figure I showed at the beginning of this presentation. It helps inform scientists areas that need to be improved. And so that gets back to the data assimilation, the way in which the system's configured, how we visualize and disseminate it, and then the verification techniques and different metric developments. It's a feedback loop between research and operations, and then back from operations to research. And that's something that we really try to practice. Okay, finally, I don't know if you've had a chance to look at the guidance in real time or not. The domain does change every day. If you go to the real-time website, you can click on a link on the right here that says View Daily Domain, and you can see if the system's going to be running over your CWA. If it does run, and if you look at it or somebody in your office looks at it, we would love your feedback. We have some questions. It's very short, this survey. It just gets at who's looking at it, so what forecast office, when, so what event are you looking at, what did you see, what was it in the guidance that you saw, what was perhaps information that you got from the guidance that you didn't get from other models, for example, and then the impact. So were you able to integrate that information into the decision making of the forecast office? Was there any impact or application of that information? Like I said, it's super short. If you want to provide feedback, you can do so by just clicking on this link on the warn-on forecast system website. It says NWS forecaster feedback, pretty explicit, and we would love to hear from you if you are using it. So that wraps up our presentation. I hope that you are a little more familiar with what the warn-on forecast program is doing. Our contact information is listed there. We're always happy to talk and collaborate with forecasters. So please feel free to reach out. And I guess at this point, if there's time, we're happy to take questions. Thank you.